Okay, let's dive right into this fascinating explainer of our source material. I want you to imagine just for a moment that you are floating in the vast, completely awe-inspiring expanse of space. The stars are brilliant, the Earth is this beautiful, fragile blue marble in the distance, and you're safely wrapped up in a highly engineered, multi-million-dollar spacesuit. But now, imagine making a mistake that lasts for literally just a single tick of a clock. Today, we're looking at a scenario that sounds straight out of a sci-fi movie, but it's actually rooted in cold, hard physics. We are going to look at exactly what happens to the human body if it's exposed to the freezing, unforgiving vacuum of space. And we aren't talking about being stranded out there for hours or even minutes. We are talking about a timeline so incredibly brief, you might actually think it's harmless. Well, as you'll see, that assumption is dead wrong. 1. A single second. Here on Earth, a second is practically nothing, right? It's a blink, it's a heartbeat. We literally ignore thousands of them every single day without a second thought. But context is absolutely everything. When you strip away the protective blanket of our atmosphere, time kind of seems to behave differently, just because the environment is so outrageously extreme. Out there in the cosmos, a single second is not just a fleeting moment. It's this profound window of time where physics and biology violently collide.
It really forces us to confront the reality of human destiny in cold space. What actually happens in that exact microscopic window of 1 second without a suit? Hollywood movies have given us, a ton of dramatic interpretations over the years. People instantly freezing into solid blocks of ice, or immediately popping like balloons. But the truth, when you look at the physics and biology, is far more complex, way more bizarre, and honestly incredibly fascinating. We're going to break down this exact second to understand the rapid-fire chain reaction and the exact reasons for these bodily changes that occur when human biology meets the absolute void.
So let's get into it with our first section, the ultimate wardrobe malfunction, a fateful tick of the clock.
Think about our hypothetical, very unlucky astronaut thinking, I'll just pop the helmet off for a quick second. What's the worst that could happen? It's actually a perfectly natural terrestrial thought. Down here on Earth, if you're wearing a heavy winter coat and get a little too sweaty, you just unzip it for a second to let the breeze in. No harm done at all. We are completely conditioned to think that brief exposures to harsh environments are manageable. But applying terrestrial logic to the vacuum of space? Yeah, that's a recipe for absolute disaster. The worst that could happen is a cascade of biological shocks that kick off the very microsecond that helmet seal is broken.
Moving right along to our next section, into the cold void, leaving the comfort zone. Let's look at exactly what we are stepping into. The sheer magnitude of this shift is just staggering. On Earth, we're enveloped in this warm, heavy blanket of atmospheric pressure. It's about 14.7 pounds pushing against every single square inch of your body. That pressure is what keeps your fluids liquid and your gases dissolved. Your body literally evolved to push back perfectly against that exact weight. But space? Space is an unforgiving, total vacuum with zero pressure, and the temperatures can plunge to hundreds of degrees below zero if you're in the shadows. When you transition between those two extremes in 0 seconds flat, the physical shock to your biology is instantaneous.
Let's define exactly what our astronaut just exposed themselves to. A vacuum isn't just empty space. From a biological perspective, it's a wildly forceful, demanding void. Because there's practically no matter and zero atmospheric pressure, it creates an environment where liquid water simply cannot exist. The environment literally wants to pull the gases right out of you. And because there's so few molecules to transfer heat, any moisture exposed to that vacuum will rapidly boil and then, crazy enough, immediately freeze. This is the harsh reality dictating our human destiny in space.
Which brings us to the core of the issue. Bizarre bodily changes. Anatomy of a millisecond. Let's look at the specific reasons for these bodily changes.
Let's stretch out this single second into ultra-slow motion so we can really see how the chaos builds. Okay, at 0 milliseconds, the suit is breached. The protective seal is gone. By 250 milliseconds, that's just a quarter of a second in, the vacuum is already pulling aggressively. All the air in the suit rushes out at explosive speeds. By 500 milliseconds, just half a second, the absolute cold hits the skin, and the moisture on the eyes and tongue begins to react violently to the total lack of pressure. And by 1,000 milliseconds, 1 full second, the biological shock is totally complete. Your body has fully realized it is in a very, very hostile universe.
If we break this sequence down into steps, you can really see the terrifying chain reaction. Step 1. The vacuum forcefully pulls away all your protection. Your body suddenly has absolutely no external pressure to push against. Step 2. The extreme cold bites immediately. As any moisture on your skin rapidly expands and evaporates into the vacuum, it pulls heat away from your body in this intense flash freezing effect. And step 3, the body reacts in sudden, extreme physiological panic. Your nervous system is just entirely overwhelmed by the abrupt shift in pressure and temperature. It's a sensory overload unlike anything a human could ever experience here on Earth.
Now let's really dive into the why. What are the specific reasons for these bodily changes? First, you get that instant temperature shock to exposed skin. Without atmospheric pressure, the boiling point of liquids drops dramatically. The moisture on your eyes, in your mouth, and on your skin starts to boil away instantly, which, paradoxically, freezes the tissue underneath because of rapid evaporative cooling. Second, and this is absolutely crucial, is the violent pressure differential on your lungs. If our astronaut instinctively held their breath when the helmet popped off, the sudden zero pressure outside would cause the air inside their lungs to expand violently, potentially tearing delicate lung tissues in less than a second. Third, we see a rapid shift in bodily fluid dynamics. Gases dissolved in the blood start to expand, a condition called ebullition, causing the skin to literally swell. All of this triggers the fourth point: immediate survival mode. The brain commands massive adrenaline spikes as it desperately tries to comprehend this sudden trauma. And remember, all of this happens in just one single tick of the clock.
So let's hit our final section, the 1-second verdict, a chilling destiny. What's the immediate aftermath for our hypothetical astronaut?
Here is the absolute most crucial takeaway from all of this. While a single second in space without a suit triggers a massive, immediate biological shock, it actually isn't instantly fatal. You wouldn't magically explode, and your blood wouldn't instantly freeze solid in your veins in just 1,000 milliseconds. But the sheer violence of that pressure differential on your lungs and the extreme temperature shock to your skin and eyes proves just how incredibly hostile space really is. That one single second would likely leave our astronaut with ruptured lung tissue, severe frostbite on their corneas and skin, and extreme physiological trauma. It is a very harsh reminder that we are entirely, 100% dependent on our technology to survive out there.
Which leads us to this final thought I want to leave you with. If just one single second, a literal blink of an eye, causes this much biological chaos, just how fragile is human destiny against the unforgiving cold of the universe? We're explorers by nature, right? Driven to push the boundaries and travel among the stars. And yet, our bodies remain totally tethered to the very specific, incredibly cozy conditions of Earth. As we look to the future of space exploration, understanding this intense fragility isn't just about avoiding a wardrobe malfunction. It's about respecting the incredible, beautiful hostility of the cosmos we are daring to step into. Definitely something to keep in mind the next time you look up at the night sky.